All right, in this video, this is part two of how to really read the SRP table. And in these questions, we're going to try to answer, is this species capable of oxidizing copper to copper ions, solid copper to copper ions? So you're going to hear me say this several times throughout this tutorial. And here's like the overlying principle. So if you're trying to figure out if so when I say when this says predicting spontaneity, we're trying to figure out, will this reaction happen? So these reactions will these reactions happen is what we're trying to figure out. So what that means is, will this result in a positive E cell? Okay, which would result in a negative delta G. So would they be thermodynamically favored, which is like coined as like the new AP term? They actually don't use the term spontaneity. They changed a little bit and reworded that to thermodynamically favored. So will these reactions happen? Here's the overlying principle. Make sure you guys write this down. So I mean the species being reduced for these reactions to result in a positive E cell, the species being reduced must be above the one being oxidized. Okay, so let's try to apply this and answer these one by one. So in part A, we're gonna write little half reactions and then find them on the SRP table. So the reduction is H plus, and remember reduction, we have electrons on the reactant side, so we're gonna have H plus with some electrons, and that's really all we need to that's all we really need to write out, and we're gonna try to find this on the SRP table. Our oxidation is gonna be copper, making copper ions plus some electrons. Okay, and so this is we're going to look for this on the reactant side. Okay, and then this will also, of course, since it's the reduction half, we're going to look for that on the reactant side. So let's try to find H plus with some electrons on the reactant side, and we see that it's right here. It's the number 36. It's actually the standard electrode. So the 2 plus um, so this one is a 0 voltage for this one. So the E red for that is zero point zero 0.00 volts. And now we're going to look for this where we have copper ions, and this needs to be on the product side. So that one is going to be reaction number 31, this one right here. Okay, so and so we're gonna this is the one being copper being oxidized. So we're gonna flip this one, and we see that it's a negative. So let's go ahead and let's take a look and reread this. The one being reduced must be above the one being oxidized. So, and what did we see here? We saw that this is the one being oxidized and this is the one being reduced. So that's not what we put in our bullet point. So this we're gonna flip this and make it a negative 0.34, and we see that it's gonna be a negative E cell. So this one, the oxidation is a negative 0.34 volts. So if you add these, your E cell would be negative 0.34 volts overall. So the answer is no, um, because the copper, or the one being oxidized, we'll write it more general, because the oxidized species is above the reduced one. Okay, so let's take a look at part B. So is Fe3 plus capable of oxidizing I minus? So our reduction is Fe3 plus. So we need to find Fe3 plus an electron, Fe2 plus. And the one being oxidized is I minus, so we're going to find I2 with some electrons on that one. Okay, so is the one being reduced above the one being oxidized? Let's take a look. So we find that Fe, now here's something kind of interesting is you'll find two reactions with Fe. We're going to find this one and then we find this one. So Fe3 plus with some electrons is here and here. Okay, we're going to choose this one, and I'll tell you why. We're going to choose this one because this one only requires one electron. Okay, so this one would actually happen before this one anyway because it takes fewer electrons. So we're going to choose this one since it takes fewer electrons for this one. Our other half reaction is I2, which is this one here. So is the one being reduced above the one being oxidized? So this one here is being so we're going to flip this one and see how that makes this a negative 0.54, but this one's positive. So the one being reduced is above the one being oxidized. So this one should happen. Okay, so this one was the E uh, reduction for this is positive 0.77. And when I flip this one, I get a negative 0.54. So E cell standard is positive. So yes, this one happens because the one being reduced is above the one being oxidized. Okay, let's take a look at part C. So we're going to write the half reactions again, find them on the SRP table. FH2, we want to show this being reduced, or I'm sorry, we want to actually show, uh, we actually want to show this one being oxidized. This is a little change up here. This one says um, Ag plus needs to be reduced. So there are reduction half reactions. This one, Ag plus electrons makes Ag, and the one being oxidized is H2. So is H2, if this gets oxidized, will that be enough voltage to reduce Ag plus? So H2, and we want to show that losing some electrons. This is the reverse of our standard, I think. So let's go ahead and check these out. Ag plus is this one here with electrons here. So this is a positive zero point 0.8. And let's see. Um, 8. H2. So H2 losing electrons is the reverse of the standard potential. So that one is. So let me erase some of this old stuff. And let's show these clearly. That the one being reduced is above the one being oxidized. So so this one needs to be flipped, and we change the sign 0 anyway, so that one stays 0. But this is the one reduced, and this is the one, this is old. This is the one being oxidized. So the one being reduced is above it. So we're going to have the reduction for this one is a plus 0.80, and the oxidation for this one is 0. So the answer is E cell is going to be positive. It's going to be 0.80 plus 0. So the answer is yes, because the reduction half reaction is again above the one being oxidized. Okay, so now here's the practice one for you guys to try. So this one is saying is H2 capable of reducing N2 plus? So be careful of the wording here. Um, is capable of reducing N2 plus. So for A, our reduction, I'm just going to kind of get you started here and give you some pointers. So be careful of the wording. So Ni2 plus, and reduction shows electrons on this side, okay, and to make some solid nickel. And the H2 must be getting oxidized. So we're going to write that with H2 with some electrons on the product side. Okay, so try to see what happens with these. And the other main point I wanted to make is to match this up with what's being said in the problem, and you should be all right. Okay, let me go back to the practice one. So that's the end of this tutorial. See what you guys come up with.